Hello, my name is Cindy Vanderweide, and the title of my lesson is How a Position Time Graph Relates to Velocity. This lesson supports Alaska Science Standard SB4, which states, students develop an understanding of motions, forces, their characteristics and relationships, and natural forces and their effects. By the end of this lesson, students will know and understand the concept of a position versus time graph and will be able to interpret a position versus time graph. I will be using the direct instruction model combined with a cooperative learning structure. Step 1, focus and review. Well, good morning, class. We're going to further our discussion today of position and velocity, but before we do, I want to take some time to review. So, Megan, I'm going to ask you a question. If you were lost in the woods or in the mountains, and all you had was a two-way radio communication with someone, how might you tell them where you are?
A point of frame or reference.
What do you mean by that? You know? Like where, what do you think? Yeah, Corey, what do you think?
Maybe like if there are like landmarks or something, you know, you're stranded in the wilderness and you need a landmark so that they can like find you.
So you see a radio tower, what would you tell the person?
Well, you try to describe the surroundings, try to describe where the radio tower was. Okay,
and so that radio tower then becomes what Megan said, the point of reference. So if I was talking to someone on the radio and I just said, I'm about 200 meters, would that help them at all?
No.
No. Okay, so based on yesterday's discussion of position, is 200 meters a position, Quentin?
No.
It is not a position. 200 meters is simply a distance, okay? Distance is a scalar quantity, right? Position, on the other hand, I am 200 meters south of that radio tower. That is what's called position, right? Right? Okay, so then velocity from yesterday. Cami, is that a scalar or a vector quantity?
Vector.
It is a vector quantity. Velocity has both magnitude, how fast I'm going, that's right, and direction, which direction I'm going, right? Speed would be the corresponding scalar. I'm going 50 miles an hour, that's only a speed. Velocity is I'm going 50 miles an hour south, right? Step 2, state lesson objective. All right, well, great job. It sounds like you were all paying attention yesterday. I want to further your understanding today of position and velocity by introducing to you a position time graph. And today you will also be able to learn how to analyze a position time graph. And that's just going to help you cinch your understanding of position and velocity. Okay? Step 3, instruction. So I'm going to show you an animation now, and I want you to just take a few seconds to look at the animation and then describe to me some of the things you see happening in this animation and the corresponding graph. Just look at it for a minute. Okay, can someone raise their hand and tell me one thing you see happening there in the graph? Quentin?
The slope of both of the lines are constant and positive.
The slopes in the graphs are constant, not changing, and positive.
Yeah.
Okay, good. Anyone else? Megan?
The slope of the red car is steeper, so it's going faster.
Okay, so you're corresponding, the red car is going faster, and you see the slope is steeper. Okay? Slope, red slope, steeper, car faster. Annie, were you going to add something?
Well, I had another thing.
Okay.
The blue car or bottom car starts at the time of 0, but the top car starts at 4 seconds.
Okay, so the top car is coming in at 4 seconds and the blue car is starting at 0 seconds here. And what else do you notice about where they're starting? Any other things? Yes, Quentin?
The blue car is starting at 20 meters?
Yes,
Would that
it's
be
meters
it?
here,
Okay.
yeah.
And then the red car is starting at 0.
That's right. So I've got the starting position of the blue car is already out here at 20 meters. So this would be my point of reference. The 0 is the point of reference. And we can see by the calibration here that this is the positive direction, right? And that's exactly right. The red car is starting at 0 meters 4 seconds into the graph, where the blue car is starting at 20 meters. Okay, very good. So you've noticed, and so the blue car, we'll say the blue intercept, is that fair enough? Y-intercept is at 20 meters. Good. Okay, so let's talk about those things that you've noticed happening based on the cars going a specific velocity. They've got a speed and they've also got a direction. They're going to the right, which has been labeled here as positive, away from 0, the point of reference, right? Okay. Now, thinking back to math class, how do we define slope of a line? Slope is found by, yes, Cami?
Rise over.
Rise over run. And the rise is the change in position or time? The y-axis or the x-axis?
Y.
Right, it's change in y, right, over change in x. And the y-axis is represented by position. The x-axis is represented by time. So I can say that slope, which is rise over run, which is change in y over change in x, right? My change in y is a change in position. My change in x is a change in time. Yesterday you learned that velocity is defined as a change in position over a change in time. So you see the slope of the line of a position time graph gives you, and now here's the important distinction, gives you the average velocity. All right, great. Well, I want you to turn in your books to page 49. You'll see a position time graph there with 4 objects represented. So I'd like you to get in pairs across the rows here and come up with a possible scenario that would describe the 4 objects you see graphed in that position time graph. All right, go ahead. Step 4, guided practice. All right, great discussion. I liked the stories I was hearing. Does anyone want to volunteer to share their story with the class? Yeah, Cami and Quentin? All right, Quentin, what story or scenario did you two come up with?
Well, okay, while sitting here, we saw your little squirrel.
Oh, yeah, okay.
What we came up with was a squirrel race
Okay.
up a tree.
Okay.
And what the graph is showing is A is a constant horizontal line, and it's not starting at the point of reference at 0.
Okay.
So what we came up with is that A is a squirrel that is sitting on a branch
Okay.
and is not participating.
Okay.
Then we have B and D, and both of them start at the point of reference, but B has a steeper slope, which means it is going faster than D.
Okay.
So we figured D would have been a fatter squirrel.
Okay, you can't go as fast. And what's your point of reference?
And the point of reference is 0 at the bottom of the tree.
The bottom of the tree, okay.
And then we also have squirrel C, and squirrel C starts up above the point of reference, so at a higher branch or its hole,
Okay.
and it has the same velocity or steepness of the slope as B does, so it reaches the top of the tree faster, and C and B are the only ones that actually make it to the top. So, because of cheating, C wins.
Because it started up the tree. What did you think? Did that make sense? Did that fit the picture?
Yeah.
Yeah. All right. Good job. Good job. Well, excellent. Okay, I'm going to give you an opportunity to practice now on your own, analyzing a position time graph. So this is just a short worksheet, 2 position time graphs, 6 questions. This will be a 5-point participation grade. So go ahead and close your books now, please, and pass these back. And take about 3 to 5 minutes to work on these worksheets. Step 5, independent practice. Okay, go ahead and finish up. And pass those forward. Step 6, closure and periodic review with corrective feedback. All right, great job today, class. Your homework for tonight is listed on your assignment sheet. We'll go over that tomorrow, as well as any questions you had on today's discussion. Have a good day.